What is going on, everybody? Just wanted to go over this concept with you. It's the quotient property of square roots, and then a couple of examples so it might help you with your practice endeavors as you prepare to get ready for this essential learning outcome on square roots. So the quotient property of square roots, quotient is the answer to a division problem. So we're talking about expressions that involve both square roots and division. So I'm going to start originally with this expression, okay? So the expression is the square root of 49 over 4. And just to kind of make sure everybody understands, this root goes all the way below both numbers, the numerator and the denominator. So let's break this down. If I take each individual part, the numerator and the denominator, and I break it down based on what I know about square roots, I can conclude that the square root of 49 is the same as the square root of 7 times 7. And the square root of 4 is the same as 2 times 2. So then if I simplify 7 times 7, well, that's 7 squared over 2 squared. And remember, if the numerator and the denominator are both squared, then I just have the exponent outside the parentheses, and I have 7 over 2 squared. So, and if you work backwards, you could actually, if I skip over here, you could actually say, just on that inside part, right, that if I have this expression, it means whatever's in parentheses is multiplied by itself. So I could take 7 over 2 and 7 over 2. And then the rule for multiplying fractions is you multiply the numerators, multiply the denominators, okay? And remember, this whole thing had a root over the whole thing. So we're right back to where we were at the beginning. So that's just kind of understanding that step can be a little bit confusing. So the other thing to think about is that these are kind of inverse operations, right? So if you square root a number that's squared, basically squaring and square rooting cancel each other out, just like addition and subtraction cancel each other out. So it leaves us with the square root of 7 squared, which is just 7, over the square root of 2 squared, which is just 2. So then if I kind of go back and take each part, the 7 is the same as root 49, and 2 is the same as root 4. So the idea is that you can write this rule. The quotient property of square root says that I can put the root over the entire fraction, and it's equal to putting the root over the numerator and the denominator separately. So here it is in algebra. Basically, A represents a number and B represents a number. And here's a fraction under the radicand. So it's one root and one fraction. Or it's A under the radicand as a numerator and B under the radicand as a denominator. They are equal in value. So let's take a look at two problems in particular. This first one, you have 2 times root 3 in the numerator. So if I rewrite that, I can't simplify that anymore. But I can take the denominator, bring the 3 down, and then I can factor the 12 into root 4 times root 3. Because remember, 4 times 3 is 12. So then I can take 2 root 3 and then keep the 3 the same, change the root 4 to a 2, and then keep the root 3 the same. Then I'm just going to use my rules of cross-canceling. As long as there's no addition or subtraction sign between the numbers, I can cross-cancel the 2. I can cross-cancel the 3. And remember, anything divided by itself is 1. Anything divided by itself is 1. So what I'm left with in this particular problem is 1 times 1, or 1 over 3. For the second problem, it's similar in that I can factor one of the numbers. So I'm going to take 12 and factor it to the square root of 4 times the square root of 3 over 5 times the square root of 3. And again, you can see the 3's are going to cross cancel, leaves me with 1. Okay? It reduces to 1 over 1. And then I'm also going to rewrite this 4. Now, I'll draw a little arrow here. 4 becomes 2. 2 times 1 is just 2. 5 stays in the denominator. And 5 times 1 is 5. So my solution is 2 over 5.